The following video illustrates what happens to ejecta from an impact on Phobos. We'll start the video, and you can see a distribution of ejecta, which in this model heads in all directions at about 800 meters per second. So that's not a real impact, but the purpose of this is to illustrate the fate of moderate velocity ejecta from Phobos in the vicinity of Mars. Ejecta that's launched from the leading hemisphere of Phobos tends to be inserted into higher orbits. In this video, the velocities that are green tend to be slower velocity, in the direction of red tend to be higher velocity. Ejecta from Phobos returns to Phobos, and you can see this in the lower left-hand corner of the screen, where orbiting ejecta intersects the point in space where the original impact took place. Notionally, that means that all of this ejecta eventually intersects Phobos at some point in time. So in a way, we call this Phobos returning to the scene of the crime. So here you see Phobos coming into the screen, and it passes through this zone in space where the original impact took place. So because of that, over time, Phobos reaccumulates this ejecta from the impacts, and of course the orbits perturb over time, and the process is not immediate. Phobos does not pass through this point in space when all of the ejecta is there, and it takes a number of orbits before there are intersections where Phobos is actually encountering the ejecta. This is a simulation, one of many models that we produced to try to understand the fate of ejecta from Phobos. Our paper discusses in detail the fate of ejecta from trailing hemisphere impacts on Phobos and leading hemisphere impacts on Phobos. And in fact, there's a possibility, particularly if there's a trailing hemisphere impact, that a fair amount of ejecta from Stickney crater winds up on the surface of Mars. Hope you enjoyed this video.